All right, Math Leaguers, here I am, I'm on camera. This is week 3 wrap up. We had some tricky problems this week. I'm gonna go kind of fast through the wrap up. Let's see. Also, before we do that, gotta give you the week 3 joke. So the question is, why did the student get upset when he asked the teacher, how'd I do in my test? And the teacher said, well, average. Why did the student get upset? Because it was a mean thing to say. Average, mean. I'm telling you, the jokes can only get worse. All right, here we go. Let's see, a cool problem. One of the problems was, I'm gonna go totally out of order here, and I think I'm only doing 3 today. And there were some tricky ones, but some of them I gave you hints on in the midweek hints. Anyway, number 15, I just thought was cool because it's over here. Number 15, it was, what is the maximum number of points of intersection for 5 line segments? Okay, well, again, sometimes it's hard to draw 5 line segments and then just start seeing how many dots you can make it touch, right? So try to find a pattern. Well, if we only have 2 line segments, they can only cross in 1 point, right? That's why I said, as long as they're not parallel and they're not laid over the top of each other, right? So then, if you think about it, it's actually pretty simple. If you add a 3rd line segment, well, the 3rd one, in order to maximize the number of points of intersection, that 3rd one would have to touch both of the other 2. So it would be adding 2. And then if we had a 4th one, in order to maximize the number of points of intersection, it would have to touch all 3 of the previous lines, so we'd be adding 3. So it's 1, and then we're going to add 2, and then we're going to add 3. Hopefully you guys are starting to get used to this. This is our triangular numbers from the Pascal's triangle that I've tried to show you before. 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10. The triangular numbers, plus 2, plus 3, plus 4. It's kind of a fancy thing, but it's from Pascal's triangle. You're adding 2, adding 3. So if we have 5 lines, that 5th one is going to have to somehow touch all 4 of these, like 1, 2, 3, 4. Kind of a little harder to get them there, but they can be done. Okay, so it's adding 4 more. So the answer to that was 10. Okay, now speaking of triangular numbers, number 13 was really cool. Now, I would not have expected you to know this, all right? But that's what we do. We hope we learn little cool tricks, or maybe you looked it up. But it said, what is the sum of the first 20 triangular numbers? Starting with 1, add 2, add 3, add 4, add 5, add 6, add 7, add 8, so on. Well, one thing you could have done is just wrote them all out. And I said you guys could use a calculator or whatever, and you could just add them all up. Now, that little trick of when you add consecutive numbers doesn't work here. When you add consecutive numbers, you know, you can like pair them off, and the pairs are always worth the same amount. But like, for example, 211 and 193 are not the same amount. So you can't really do that, okay? But there is a cool formula. But before I show you the cool formula, really cool, I'm gonna show you a different cool formula just to figure out what is the 20th triangular number, other than like writing it down. If I just said, what's the 20th triangular number? Well, the nth or whatever numberth triangular number is that number times that number plus 1 divided by 2. So for example, the 20th triangular number 20 times 21 divided by 2. Well, if you cancel the 20 and the 2, that's 10. 10 times 21 is 210. 210, okay? kind of cool. It works for all of them. Not really relevant to this problem, other than to just make sure you know when you got to the 20th number. But then there's another formula that the sum of n amount, like 20 or however many amount of triangular numbers, is that number times that number plus 1 times that number plus 2, all divided by 6. Really cool. So for example, just with like the first 3 numbers, 1, 3, 6, that all adds up to 10, right? Well, think about it. It's the third number, the sum of the first 3 numbers. So it's 3 times 4 times 5, which is 12 times 5 is 60, divided by 6 is 10. 1 plus 3 is 4 plus 6 is 10. It works for all of them. So for the 20th, for the sum of the first 20, we do 20 times 21 times 22, all divided by 6. You can do some fancy canceling, which is kind of cool. For example, the 20 and the 6, you could divide by 2, you get 10 and 3. And then with the 21, you could do 3 into that goes 1, and 3 into that goes 7. So you don't have to multiply big numbers, like if you didn't have a calculator. You could do 10 times 7 times 22. Or even better, 7 times 22, which is a little easier to do in your head, 154 times 10, 1540. Okay, so that was that one. And then finally, number 20 was so weird. There's a pattern. When you look at squares, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. There's a pattern. Between the squares, it goes up by 3, goes up by 5, goes up by 7, goes up by 9. So there's like a constant in there. It's up by, the raise of the raise is up by 2 every time. Okay? So there's got to be a formula. Well, the formula is, the question was, like, what if someone could square 3, but their mind can't handle squaring 4? So how could they use squaring 3 to find 4 squared? Like if they had some weird mental block. All right, it's a weird question. But, so we're gonna use like just these 2 really small ones, 9 and 16, to just show the problem, make it simple. So let's say they couldn't do 4 squared, but they could do 3 squared. Well, we're assuming they could do 4 minus 1, which is 3, and then they could do 3 squared is 9. Now they have to add to it. Well, they have to add some kind of odd number, right? Well, what odd number is it? Well, when you're between the 3rd and the 4th, you're adding 7. Think about that. Between the 3rd and the 4th. Think about 3.5 doubled is 7. So anyway, it's a little bit weird. You take 2 times the number that you can't do, 4. Can't do 4, you can't 4 squared, but you can do 2 times 4. Okay, so 2 times 4 is 8. You're at 17, and then at the end, you have to subtract 1. It would work the same. Let's look between 16 and 25. Let's say you could handle 4 squared, but you couldn't handle 5 squared. So 4 squared, or like 5 minus 1 is 4, squared is 16. 2 times 5 is 10, minus 1 is 25. So then I wrote this weird formula. It was n minus a, so a is 1, plus b times n, b is 2, and then minus c, c is 1, and I asked you to add up those numbers, and that was 4. Weird problem, but fun problem. All right. Looking forward to week 4. Keep your eyes open. Week 4 we'll have another bonus challenge. The week 5 bonus challenge is going to be the Kahoot game, and that'll wrap things up. And I apologize, we are still working on t-shirts. They're coming, all right? Ms. Tanya does have some cool math t-shirts on her website, but not our official math lead t-shirts. Not quite yet. We're getting there, and have a great week.